Hello, welcome to this demonstration video for the WYE and Delta shop jobs. I've changed them from the original versions to T2 and T3 for the online portion of the 275 ECMN shop class. We're going to take a look at the schematic first for the Delta shop job. Here you're going to see lamps 1, 2, 3, 4, 5, and 6. Right here is a representation of our safety disconnect that you should be familiar with from SDS Job 1. Right here are the cartridge fuses that sit inside of that safety disconnect. And remember, we have 208 volts between line 1 and line 2 and line 3, vice versa. We would measure, if there was a neutral in this drawing, 120 volts from any of the lines back to neutral. So right here, if we were to call this A phase and this B phase, or if we call this A, this B, and this C, measuring between any one of those points with a voltmeter will give us 208 volts. So in a delta configuration, with the lamp configuration, each lamp will be in series with one another between each phase. In a delta system, E line equals each E phase because of that. We don't have a neutral to measure to. I line is greater than I phase by the square root of 3, or 1.732, and this is because it has more than one path for current to flow. Okay, so the current coming in on the line, alright, will be greater than the phase, this each being a phase, by the square root of 3, because it has more than one path for current to flow. Alright, as far as the shop job goes, if you're following along with the measure and record tables, for lamp 1 and lamp 2, if they're in series, that means that voltage should split proportional to their resistance. Since this is a balanced load, we should see an equal drop in voltage. So from A to B, we would see 208. This means that each bulb should measure about 104 volts. So go ahead and fill that in on your shop job. If you measure the line current to be 3 amps, for example, you can calculate the phase current by dividing by the square root of 3, or 1.732, and you'll be able to calculate that accordingly according to 3 amps. Okay, you should use that example for your shop jobs. Okay, for an unbalanced load in the delta system, for this table, assuming you have a 100 watt and a 50 watt in each phase, the 100 watt light bulbs being 1, 3, and 5, the 50 watters being 2, 4, and 6. The 50 watters will have slightly higher resistance, or twice as much resistance rather, as the 100 watt light bulbs, which means that it will cause more voltage to drop at the lower wattage light bulb. Now what this means is that the 100 watter might not appear to be as bright. The 50 watter might appear to be a little bit more bright. But either way, current flow will go up or down. For this example, again, we're going to use 3 amps on the line, so you can calculate the phase accordingly. Alright, for the Y schematic, it says here T5. Again, I modified the actual shop job to be T3. Okay, the WYE Light bank for shop job T3. In a Y connected system, all the lamps are connected to one single common point. Okay, this means that from one of the phases to where the other side of the lamp is connected, okay, so from one of the phases right here to where this lamp is connected, that is our neutral. That is our return to the source. This point can be connected to neutral or ground, or it can be left unconnected altogether from the source or ground, so long as it's all tied together. So we could remove this neutral wire, okay, and just have all 3 of these bulbs connected to each other, and with alternating current, so long as there is a path back to the source, current will flow. Alright, for the balanced load measurements on the shop job, line voltage A to B is just like you were measuring right out of the safety disconnect for SDS Job 1. You'll see a 208 volt measurement there. Lamp 1 will measure from line 1, or the A phase, to neutral, or the common point, and that should be about 120 volts. Alright, and then in a Y connected system, we should be familiar with the fact that line current and phase current are exactly the same, because it is in series back to the common point, and there's only one path for current to flow. With an unbalanced load measurements, you'll see small voltage swings depending on how unbalanced the load is, but only once the neutral is removed. Typically, a neutral will balance the load out. That's the job of the neutral, to carry the unbalanced current back to the source, allowing the voltages to stay at full voltage. Alright, for an unbalanced Y with no neutral, for this one, assuming a lamp is only 50 watts while B and C are 100 watts, here you will notice the lamps appear to be off or more bright than usual. So in other words, when you're looking at them, if you were in shop class, you might not even think that the lamp is actually on, but if you look closely, you could see a small glow of the filament inside. We know that it's working because without a closed path for current to flow, none of the light bulbs would appear to be on. No current would be measured or flowing. So for an example, the 100 watt might measure 80 to 90 volts, while the 50 watt measures quite a bit over 120. So it'll be a noticeable difference. All right, for this one, current is the same on the phase and the line. Thanks for watching.